Primarily, this is the last class session. This is on the final exam review. Now, frankly, normally I like to start off with explaining some of the aspects of the final exam, such as the number of questions, the amount of time, and all of that. And frankly, the test has not been written yet. I don't write the test, so I can't take the blame on this one. So I cannot give any information, and I can only provide that information when it's given to me. The only thing I can say definitively about the test is that 2/3 of the final exam material is covering the Unit 4 material. And so to give a good idea what this is under lecture links, I have at least the Unit 4 ones written in. So all the stuff from systems of inequalities, 2/3 of that material is going to be on the exam. So maybe a linear programming problem, graphing some linear inequalities, might be one of those on there. And a few other things. And also, now that I'm thinking about it, I did receive, so I need to send this out. This PDF right here, this will be the scratch work for your final exam. I got to send this out. I just received this. And so notice it tells you solve by hand using substitution or elimination. So you can kind of get an idea of what problems will be on here. So, and notice they do give you a graph for the linear programming. So I guess they do tell you the number of questions. So I take that back. There's 16 questions on the test. Sorry about that. Yeah, there's 16 questions. Still don't, I would imagine it's 80 minutes to take the test, unless you have time and a half. And so I need to send this out as soon as possible. So if I don't mention anything about this, just someone email me and remind me. But you're going to print this out or write this down on a scratch piece of paper. And this is what you're going to submit to me through the shared Google Drive folder. So I can give you, partial credit, because I know you all want partial credit. So just keep in mind that expect to receive this whole PDF file from me at some point, or I'll post it. Oops. Okay. Yeah, and you didn't have to schedule the test at 8. You could schedule the test at any time that was available on there, 8:20. Some people like scheduling it earlier. But yeah, you could schedule it for whatever time was, whatever time showed up. But besides for that, can't really think of anything else. So there are 16 questions on the test. I think there's 80 minutes, but I'm not too sure yet. And besides for that, 2/3 of the material on everything from systems of equations and onwards, and then 1/3 of the material from the stuff we talked about in Unit 3, which was on pretty much the statistics stuff. And of course, yeah, you could use your TI 83, 84, 89 calculators. You can have your answer sheet with you and all of this stuff. And if you have not signed up for the final exam, you definitely have to do that tonight. You definitely have to do that tonight. But I feel as though that's everything I can think of. And of course, I hope you all know we're taking the test through ProctorU, which means you take the final exam on your own. Don't take the test in a public place where people are going to be walking around you, or the proctor is going to stop the test and tell you to move to another place or reschedule the test. Make sure you test the equipment of the computer you're working on. One of my students said that the test failed because their monitor size was too small. I didn't even know that was a thing. So please test your equipment now. You have a Linux operating system, you can't use it on Linux. There's a few little nitpicks that they exclude, like you can't use Chromebooks or iPads or stuff like that. So please make sure you test your equipment and you find out sooner rather than later that you have a technology issue. That's why I'm so adamant about this right now. And so I believe that's it. Let's go ahead and start with the final exam review. So you'll notice at the bottom here, there's practice problems for final exam, and there's a few assignments due as well tonight. The final exam prep quizzes are for a grade. I've gotten a few emails about that. They are for a grade, but they're not, as you can see, they're not actual quizzes in terms of it's problems like these. So, I hope you can get the quick points from those. Oh, we're going to go ahead and start with the practice test. Okay, so you may recognize this problem here is a weighted average problem that we did in the statistics section. A student's course grade, they have a midterm that's 20%, a class project that's 20, sort of homework that's 45, and a final that's 15. And so this is one of those, again, this is one of those weighted average problems that we talked about in class. So the midterm is 20%. And it goes on to say that the midterm was 76. Okay. So the midterm is 20%, and the midterm score was 76. So there's a multiplying 76 by 0.2. I'll use another color for the next one I see. Class project is 20%, and the score is 86. So I'll go ahead and add, oops, not that. $86 times 0.20. Okay, and so what's the next one? The homework is 45%, and the homework score is a 94. So 94, and that is 45%. And you might see where I'm going with the last one. Final is 15%, final exam score is 74. Let's see what this comes out to be. $76 times 0.2 plus 86 times 0.2 plus 94 times 0.45 plus 74 times 0.15. And we get 85.8. So guess what the overall final score is? 85.8. Provided I typed in everything correct. Okay. Straightforward. Any questions? Okay, cool. Let's keep going. Okay, this is another statistics-based problem. So hopefully you remembered the Z's. Those are the Z scores. And so what this is asking for is determining how these Z scores correspond to grading really boundaries. So the Z scores establish what minimum or maximum grade or grade range that one would need to get an A, a C, a D, or an F. tell us some important information. The average is 80. The standard deviation is 5. We're going to be using this to our advantage. So for part A, or for an A letter grade, it's saying that an A is when the z-score is greater than 2. So they want to know what percentage that corresponds to. So if the average is an 80 and an A corresponds to when the z-score is greater than 2, well, that means we have to add the standard deviation twice. 2 times the standard deviation. Because the z-score is 2. Oh, wait, why did I put 10? I'm thinking ahead, I'm sorry. Not 10. 5. Because the standard deviation is 5. Because an A grade refers to when the z-score is 2 or higher. So how do we get a z-score of 2 or higher? Well, we need the boundary. The z-score is 2, so we add the standard deviation twice the mean. That's simply 90. So that part isn't too bad. So here, this one's pretty straightforward. 90. So again, an A is when the z-score is greater than 2. The boundary is when the z-score is 2. What grade does that correspond to? It's the average plus 2 of the standard deviation. So we can move on. I'll just move this up here. Okay. So let's keep going to a C. So they skipped B, and now we're looking at C. So a C grade, it tells us that the range of values that would constitute a C grade are in between a z-score -1 and +1. So so the question is, how do we end up with these? And so there's two boundaries here, the -1 and the +1. So I'll do both of them down here. When the z-score is -1, this means you take the average. And we're actually multiplying the standard deviation by -1. We're adding the standard deviation -1 times in this weird kind of wording. But really all this refers to is 75. A z-score of -1 means we're 1 standard deviation below the mean. So that's why I'm going from 80. 1 standard deviation is just 5. So that's why we get 75. Then we could do the same thing for a z-score of 1. That means we're 1 standard deviation above the mean. So the mean is 80. And we are adding 1 times 5 just to get 85. Actually, I think I'm getting this wrong. Wonder if anyone noticed it over here. Okay. The wording's a little tricky here, so I don't think 90 is correct in the first one. It's not asking for what percentage would give an A. It's asking for what percent of students will end up with an A. Okay, that caught me off guard. That's a good question. Yeah, what percent of students will end up with an A in the class? We know that 90% is the boundary. So really what I'm thinking here is that 10% of students will end up with an A. So a 90%, actually, no, it's not 90% either. It's the 68, 95, 99.7 rule. So, okay, this wording completely threw me off. Okay. So, guess what? I did all that wrong. How embarrassing. All right. Let's try it again. So what's happening here, I should have saw this sooner. Normal distribution means that the percentage of people that fall within a certain range of values are, so hopefully you all remember the 68, 95, 99.7 rule, which refers to 1 standard deviation, 2 standard deviations, and 3 standard deviations above the mean or away from the mean. That explains the percentage of people in those certain ranges. So here, what it's saying is what scores correspond to a z-score greater than 2. And what this is referring to is what values, I know that's right, but find the test scores. But then what percentage of students? Is this a broken problem? Find the test scores for each grade interval. And then here it's asking for what percentage of students. Well, how about that? There's a broken problem on here. So I was doing it right before. Well, yeah, I think this is a broken problem. So I was right the first time. Okay. They want you to find the test scores, and then they ask you to find the percent of students. That's not the test score. So that's a broken problem. So it wasn't my fault after all. It's a broken problem. Because I doubt they want you to find the percentage of this without giving you the graph for it. So there's nothing we can do with this problem. It's a broken problem. If you want an equivalent problem to study or to be aware of, I actually had one in the notes that is not broken. Let me pull that one up. So whoever made that, a broken problem on. Interesting. Who was it? I know we've done a problem like this before. Okay, example 9 on page 44 of the notes. This should be, yeah, example 9 on page 44 of the notes. This is how the question should look. Number 44, example 9. It should be find the test scores, and then they ask you for the test scores. That's what they should do for this problem. But whoever put this problem on the practice test did not do that. They put a broken problem. So all that's an elongated way of saying study, make sure you're familiar with example 9 from page 44. And so maybe, so go ahead and be familiar with that one. We're going to go ahead and continue with another problem. Because the scope of this problem, you're not expected to do what they're asking for right here without, they normally give you a graph. So this problem doesn't make any sense. So sorry about that. Okay, I think this is a good conceptual problem. So we talked about matrix operations. And so which one of these doesn't depend on the size of the matrices? And so, well, right here, we could think about addition. Not saying addition's right or wrong. One of the issues with addition is if you try to add a matrix of this size plus a matrix of this size, it doesn't exist. The dimensions have to be the same. So that's kind of what they're referring to here. The size does matter for addition. So this one does depend on it, so it can't be answer choice A. And subtraction is the same way, because addition and subtraction are very similar operations. So now it's a question of, so which one of these does care about matrix size versus does not? And so hopefully you remember that you cannot just multiply any two matrices together. When you multiply matrices together, actually this one would end up working. When you multiply matrices together, if the inner numbers do not work, or the inner numbers do not equal, then the matrix multiplication doesn't make any sense. That's why it's only multiplication by a scalar, because you can multiply a singular number into every single entry in the matrix. So multiplication by a scalar is the only one that does not depend on matrix multiplication. All right, so we have a box plot. And so we talked about box plots, not in too much detail, but we did talk about them in the notes. So remember, it's the median, Q1, the first quartile, and then the third quartile, and the minimum and maximum. And so the regions from lowest to highest in terms of the median rate, really they're wanting us to rank these based off of where the median lines are at. So we have median lines here and here. It's the dash in each one of these. So they want us to rank based off of those middle lines. So that's how you read a box plot. That's the median. It's that line in the box. And so they want this from lowest to highest. So the lowest one is C, followed by D, and then A, and then B. Because that's where the dashes are at in the box. So that's what they're wanting us to rank off of so far. And then part B wants the largest interquartile range. So this is the largest box. Which one has the largest box? The interquartile range. Inter is between, quartile are the quartiles. So which one of these boxes resembles or illustrates the largest difference between the two quartiles? And hopefully it's clear that this is region B. It's got the largest box. And then they want the smallest one. That seems to be obviously A. And then they go on to ask as well, which one of these regions has a potential outlier? And so remember, outliers are values that stray far away from the summary of information. So as I look at all of these, the potential outlier that seems evident to me is in region D. Because in region D, the maximum part seems to be very far stretched away from the box, which is where 50% of the data is supposed to be happening. For all the other ones, those line segments do not stretch too far away from the box, relatively speaking. So that's the one that seems to have the biggest potential for outliers, region D. And so finally, why is a rate of about 23 million errors per 1,000 in region C a potential outlier? Well, rate of about 24 in region B is not. So what they're asking for, so let me erase all of the illustration stuff I have over here. So they say in region C, 23 is an outlier. Oh wait, that actually answers part D then. It's C. It's not D. It's C. Didn't even see those dots there. Oops. The potential outliers, that one's C. I didn't see the dots. Okay, so they are wondering why 23 is considered an outlier for region C, as opposed to 24, which is very close to 23, is not an outlier in region B. So 23 would be virtually right here. And so here they want us to kind of use that definition of finding the fences, which we normally use 1.5 as a multiplier. You remember the definition, Q1 minus 1.5 times the interquartile range. So here they're just asking for the definition of the fences, which the fences in statistical context refer to the boundaries that contain the usual events of information. Everything outside of the fences are considered outliers. So if you didn't do so already, potential outliers is C and not D that I had earlier. Okay. Move on to problem 5. And so we're going to go ahead and graph the solution for this. So as you already noticed on your test, which I did download. So to kind of detour right fast, they do give you a graph. They do not give you the, I mean, perhaps you can assume that they go by increments of 1, but yeah, just keep in mind that for the linear inequality stuff, they will give you a graph, as well as the programming stuff. They do give you a graph, which I'll post that whole thing in my math lab later on today. So hopefully you know how to do this by now. We graph both of these individually by finding the intercepts. So this is the stuff that we talked about again and again and again, not only in graphing linear inequalities, but also the linear programming stuff. So hopefully you know where to go from here. And so the x-intercept, hopefully you remember you set y equal to 0 for the equality. Let me just get that x is -4. Y-intercept, we set x equal to 0 and solve for y. You get that y is 1. I'm going to go ahead and do the same thing for the other one as well. We'll find the x-intercept and the y-intercept for this one. The x-intercept, you set y equal to 0. So we're going to get x is 3 ultimately. And the y-intercept, set x equal to 0, y is 6. And hopefully it's clear that all the lines are going to be solid. All the lines are going to be solid because we have an equal to part in each one. So we have an equal to component in each inequality. So all the lines are going to be solid. So if anything, let's go ahead and plot these lines. So here, the x-intercept for one of the lines was -4. And then the y-intercept was 1. So the line's plotted for us. And then for the other one, the x-intercept is 3 and the y-intercept is 6. So it looks just like this. And then finally, we need to figure out the shaded component of all of this. So if anything, it might be good for us to sort of give a little note of which one is which. This one's the blue line. This one's the red line. So when we find the shading criteria, we know which line to stay or to shade on top of versus below. So for the blue line, we're going to go ahead and test 0, 0, or you might have already seen greater than sign. Well, let's see, for the blue line, when we test 0, 0, what we get, 0 minus 4 times 0 is greater than or equal to -4. And ultimately, 0 is greater than or equal to -4, which is a true statement. So that means for the blue line, we need to shade on the side connecting to the origin. So this may be a little bit different than your impression from the linear programming section. The reason why it's a little bit misled here is because we don't have the non-negative restrictions. So for the blue line, we have a true statement, which means we need to shade on the side of the origin. So far, this is what we have. This is what we have now. But that's broken up into two regions, either to the left or to the right of the red line, which is L2. We need to test that one as well. And so here it's 2 times 0 plus 0 is less than or equal to 6. 0 is less than or equal to 6, which is a true statement. So that means for the red line, we need to shade nearest the origin, which is why we only shade this region in the bottom here. So that's why we shade this bottom region down here. Okay. So here, y is 1, x is -4. The other two, 3 and 6. And we shade it down here. Save. All right, cool. All right, let's go ahead. Does anyone have any questions before we move on to the next one? Okay. You might remember this problem. This one was a little tricky. So there's a supervisor, an inventory manager, 6 stock boys, so 1, 2, 3, 4, 5, 6, and then 4 drivers. So 12 people in total, and they're paid various amounts. They want us to find the mean and the median wage. So with this problem, the reason why this one was tricky was when people would find the mean for this, or you could also just go ahead and directly plug this into your calculator if you want to figure out the mean and median that way. But when you do it, you need to make sure that the values that you're listing, so there's 1 supervisor, so I'll just list out all the values. There's 1 supervisor, there's 1 inventory manager, there's 6 stock boys, so 1, 2, 3, 4, 5, 6. So people, generally people forget to put the 6 versions of 450, and then there's 4 drivers at 520. So in addition to this, 520, 520, 520, 520. So that's what you would have to put in your calculator. And this may be good to do now to make sure, because on the final exam, you will need to know how to do the statistical stuff. So I'm going to go ahead and do it in my calculator as well. 3, 4, 5, 6. 1, 2, 3, 4. And so we all typed in everything in the same way. I get the mean is 575. Remember, it's the very first number. That's the mean. And then if I scroll down, I see that the median is 485. So hopefully you all got those answers as well. This may be something to, again, this may be a process that you might want to just confirm that you know how to do in the calculator, because it's been a while, and this will be required for the test to do things like this. But primarily, the interpretation is the last thing. And So we're asking ourselves, is the median or the mean the best measure of the center? And so really the median is going to be the best, just before we even specify the which answer we choose. And the median is the best because, well, the mean is affected by the outlier. So what's the outlier? Here, supervisor makes a lot more money than everybody else. So that supervisor's weekly earnings is an outlier. And in fact, they also consider the inventory manager's salary an outlier as well in the descriptions. So I'm going to select answer choice A. The mean is not a good measure because it's affected by the two higher salaries. That's the two outliers here. The mean is a qualitative measure because it takes everybody's salaries into consideration as opposed to the median, which is quantitative. So that's why the median would be good here. Doesn't get too bogged down by outliers. Which is why it's normally good to have a bunch of measures of central tendency, as it gives you an idea of interpreting the center, because not every mean is the same. Does anyone have any questions about this? Let's move on. Right, the coefficient matrix and the augmented matrix. So hopefully you can all do this one pretty quickly. They just want you to take, so the coefficient matrix, all coefficient means is number in front of variable. So list all the numbers in front of variables. That was fun. And the same thing, but now throw in those constants. So this is stuff from really the very beginning of the third unit. So we're just taking all the numbers 4, 8, 5, 3, -4, and 2, and you could see them pop up in the matrices as such. So let's just breeze past that one. And as you can see from, I'm going to detour right fast. What was that? Downloads, here we go. So as you can see, they do mention they do provide you the A through Z stuff in terms of the idea that there's going to be one encryption problem on here. So there's one encryption problem on here. So this one might be good practice. So they give us this message and we're trying to decode this message. And so hopefully you remember with decoding, you have to find the inverse of this matrix. Or if anything, you need to establish the inverse. To decode, use A inverse, not A. Decoding, and I guarantee some people are going to miss this on the test if they ask you to decode. But you want to use the inverse. So in your calculator, this is what you can do. So blue, I'm going to put what I recommend you do in the calculator to make this as simple as possible. Make A the matrix 1, 2, 1, 3. Because you can do the inverse in the calculator later. Oh no, not this again. Really? That blows. I'll figure it out later. Okay. In the meantime, B is going to be the message. This message, though, needs to be formatted in a very specific way. So for each number, we're going to go down, but then we're going to keep it at 2 rows so we can actually multiply to the matrix A. So 49, 73, and then we start over. 47, 66, 30, 45, 6, and then 6 again, and 69, and 94, and 39, and 52, 5, 65, 68, 93. So you need to program all of these, or both of these, in your calculator. I'll go ahead and do that as well. So matrix A, it's going to be a 2 by 2 matrix. And 1, 2, 1, 3. Matrix B is going to be, so let's see, this one was 2 by 2. And this one is 1, 2, 3, 4, 5, 6, 7, 8. 2 by 8. This is a 2 by 8 matrix. It's not the most fun problem, but let's go ahead and see what this comes out to be. 5, 6, 94, 52, 65, 93. And so what we can go ahead and put in the calculator, so in the calculator, A with the inverse symbol, so we talked about that already, and you can actually just go and pull up matrix B as well. You don't even have to put a multiplication symbol. If you did all of that correctly, I'm actually just going to write out what the answer ends up being. What you end up getting, so again, I'm just going to write out the matrix so I don't have to write this twice. 124, 9, 19, 0, 15, 6, 0, 19, 25, 13, 13, 5, 20, 18, 25. So since we're decoding, it makes sense that we get numbers that are, you know, discernible with letters. So I wonder if I can figure this out. Okay, so you figure out a few of these. That's A, and that's a space, and that's a space. There's notes. Okay. And if anyone figures out this message, just go ahead and tell me.
Axis of symmetry.
Axis of symmetry? Okay. That will save some time. Axis of symmetry. Axis of symmetry. And if for some reason you type it in lowercase letters and it marks it wrong, I could just go right behind and mark it right. It's not a big deal. If you put it in lowercase or uppercase, this is good enough. I'll just go right behind and just give you the points back. So does anyone have any questions before we move on? let's move on. Okay, it's one of these problems. So hopefully you recognize two of these. So two of these are non-negative restrictions. It's the first two. And if you can make that identification, that means you can go ahead and knock those two out really quickly with lines on the X and Y axes, as we did we did this a lot in the programming section. So there's two of them right there. Now we need to graph the other two. The Y is less than or equal to X and X is less than or equal to 5. So for both of those, we need to graph those individually. So one of these is Y is less than or equal to X. The other one is X is less than or equal to 5. The interesting thing here is that, well, let's see. If we were to find the X and the Y intercept, you said Y equal to 0, and then you just get that X is 0. The problem is you also get that the Y intercept is 0. That's not really going to help you construct the graph. So this is pretty much the only situation you encounter this in. What you need to do is go find another point. You choose X is equal to 1, then Y is also equal to 1. It's one of those lines that's so trivial, but because of its triviality, it makes it a little bit complex to think about. So in other words, the graph of Y is equal to X so the second point I'm plotting here is 1, 1. It's really it's a perfect diagonal. That's what Y is equal to X is. So this is Y is equal to X. And the line is solid because there is an equal to part. That's the only situation I've ever seen that in where the intercepts do not suffice. In fact, it can only happen for this line. So you have to go find another test point. So additionally, we have X is less than or equal to 5. So we're trying to graph X is equal to 5, which is actually, we don't even need to graph this one because X equals to 5. We've already talked about this as a line. So where's the x-axis? The x-axis is horizontal one. Where's 5 at? 5 is right here. And so X is equal to 5 would have to be a line up and down. Just like that. That's the line that corresponds to X is equal to 5. It's a vertical line. So we've talked about this when we introduced linear equations. So we don't even need test points for this. Test points help us graph the line, but this one is by default a very very well characterized and very quickly to identify graph because of its simplistic structure. There's no Y, in other words. And so now we need to figure out which region to shade. Now, because of the non-negative restrictions, this one was x is equal to 5. So because of the non-negative restrictions, we know, if anything, we're going to be staying in the first quadrant. So we're going to be shading one of those 4 regions, either this one, this one, this one, or this one. And so which one we shade is based off of the shading criteria. Now, there is an issue with one of these. That y is less than or equal to x problem. So normally what we do is we choose the origin, which is right here, and we shade the region that is closest to the origin. But with the diagonal line goes through the origin. So that doesn't make any sense. We cannot use 0, 0 as a test point for the diagonal line. Because what side do you shade on? You shade on the side of the origin, but it splits the origin in half. So which side do you shade on? And it doesn't make any sense. So we have to pick another test point. And I could pick the test point, so not this one. So I'll pick another test point that's a little bit more discernible. So what about right here? Because now it's clear that for the diagonal line, we either shade on that side of the dot or we shade away from that side. So really what we're testing is, well, that looks like the point 2, 0. And so 2 is x, 0 is y, so 0 is less than or equal to 2, which is true. So we're going to shade on the side that is closest to that point. So far, this is what we have. We have those 2 regions shaded. And we need to use the vertical line to help split up these regions and help us determine which singular region do we shade. And so with the vertical line right here, we can use the origin as a test point because it's very clear that we can either shade on the side of the origin or away from the origin. So let's test 0, 0. So that's an x and that's a y. So all we can do is plug in 0 for x. Y is equal to 0 doesn't even get used here. We get a true statement, which means we shade on the side of the origin. So we shade that little region down there. It's right there. So we shade that region right there using the shading criteria. Okay, and then finally, they want us to determine the vertices of the region. So we're not done, but we're very close. The vertices of the region, right here, and right here, which we can very easily use the graph to determine. 0, 0 is one of them. 5, 5 is another. 5, 0 is the third one. Those are the 3 ordered pairs for the vertices that correspond to the shaded region. So let's go ahead and type that in. Okay. Suppose let's keep going. Okay, so they give us a table of information, and really we don't have to read the paragraph too much because they summarize the paragraph in this table for us. I guess the only thing we need to see is what the matrix A represents. And it seems like they're saying matrix A is the table itself. So really what we need to do is click on the little matrix thing down here. So it looks like there's 3 rows and 2 columns. So they want us to just rewrite the table. 2, 3, 22, 27, 3, and 3. So that's a matrix A. It says the information in the table is matrix A. Additionally, we then ask, well, what is matrix Q then? So it follows to say, what is matrix Q? So I guess the paragraph is helpful here. So matrix Q is the quantity of each type that Julia ate. It says Julia ate 2 servings of one thing and 5 servings of another. And so I suppose the only thing we have to figure out is, well, the matrix Q, so here it clearly refers to 2 and 5, but do we write that like this, or do we write it as this? Well, we need to multiply A and Q together. And if A is a 3 by 2 matrix, then I suppose the value for Q for the number of rows also needs to be 2 for this multiplication to make sense. So it does have to be this size, because the other one is 1 by 2, which means that multiplication wouldn't make any sense. So matrix Q is 2 rows, 1 column. Two by 5. And then the product A times Q. Oops. Okay. So the product A times Q, did you figure it out already, Olivia?
19.
1 second. What's the size?
2. 3 by 1.
3 by 1? Okay. So what are they?
19. 171 and 21.
And 21. Cool. So if you multiply everything correctly, you should get a 3 by 1 matrix, it seems like. We can always confirm this. The matrix A was 3 by 2. The matrix Q is 2 by 1. The inner ones match, and the outer ones tell us that the final dimension should be 3 by 1. Okay. And so finally, they want us to determine what the entries of AQ represent. It seems like it is, just choose one of these. So if A here represented the table of information, Q was the number of servings of 2 servings of Delight and 5 servings of Flakes, which seem to be the 2 cereals. So it seems as though my issue with saying that it's either one of the top or the bottom is that the matrix Q had 2 and 5 involved. So it's not just determining one of those things, it's determining really both of those things in consideration. So that's why I'm more tempted to pick the middle option. It's not just figuring out 2 servings of the Delight cereal, as they call it, or 5 servings of the Flakes cereal. It's actually determining both of those in consideration because our matrix Q had both 2 and 5. So I choose the middle option. Okay, let's look at another problem. Okay, so let's go ahead and graph this inequality. 2x plus 5y is greater than or equal to 10. And the first thing we do, as we've done before, is graph the equality. So as you already saw from the scratch work that I'll be posting on my math lab probably right after this class, is it seems like there's going to be 2 linear inequality problems. I'd imagine one of them is going to be a little bit more simplistic, and the other one's going to be a little bit more complex. That's what I would imagine. So maybe something like this may be the first one. And so if we go ahead and find the x and y intercepts, so the x-intercept seems to be 5, the y-intercept seems to be 2. And we can go ahead and plot those, 5 and 2. The line will be solid as well. So the line will be solid because there's an equal to in our inequality. So what did I have? 5 and 2. Save that. And now we need to figure out which side we shade. So we can use the test point of 0, 0, because here it is clear that 0, 0 is on one of these sides of this line. And if we get a true statement, we shade near the point. If we get a false statement, we shade away from the point. So 2 times 0 plus 5 times 0 is greater than or equal to 10. So then we get that 0 is greater than or equal to 10, which is false. So we shade away from the point. That's why we are going to shade up here, away from the origin. Which was down here. Oh, wait, it was away. Five, 2, shade up here. Save. There we go. Let's keep going. Okay. So let's see what other type of problems we have. So hopefully you can look at this one here. The reason I'm skipping 12, I believe I did this one in my notes. So let's look at other problems that may be a little bit more unique. Hopefully here you can see that you cannot add these two matrices together. Even if you put these in your calculator and try to do the matrix addition, it will tell you that it's not defined because the dimensions aren't the same. So that's a quick one. Let's skip. Okay. This is the fixed problem from before. In fact, I'll go ahead and just do this one. So this is what the problem should look like from that issue we had in the very beginning. The average is 80, standard deviation is 7. And so you need to figure out the test scores to receive an A. So this one was the example 9 from page 44, I believe, that I mentioned before. So to get an A, you need a z-score of greater than 2, which means that you need to add 2 standard deviations to your average. So in other words, your average is 80, and you need to add 2 standard deviations to your mean. And that seems to be 94. So this is what the problem should have looked like. So you need, to get an A, you need a 94 or greater, not or lower, or in between. Just need a 94 or greater for an A. And so we can do the same thing for the B grade. So for the B grade, it says between 1 and 2 standard deviations. So for 1 standard deviation, and this is above because the z-score is 1, then that will be taking the mean and adding 1 times the standard deviation, which is just 87. And then 2 standard deviations above, which is the upper bound for a B. Well, we actually already did that. It's 80 plus 2 times 7, which is the 94, which it makes sense. If you don't get high enough for an A, then that starts to become the B range. So that actually makes sense. So for a B grade, is going to be between 87 and 94. And then for C, we can already foreshadow for C, the upper bound is going to be 87. Because when you're not high enough to have a B grade, it drops down to a C grade. And then for a C grade, we figured out the upper bound. We need to know the lower bound, which is a standard deviation of so Z is -1 or 1 below the mean. So this is 80 plus -1 times 7. So we're just subtracting 7. So that's 73. For C, it's between 73 and 87, which means for a D, that already tells us the upper bound is 73. And so we figured out the upper bound. Now we need to figure out the lower bounds. So that's Z is equal to -2, 2 below the mean. 80 plus -2 times 7. That's 80 minus 14. So it's 66. And then an F is 66 or lower by boundary conditions. So I am out of time. So that is all I have for this semester, really. Do you have any questions about the practice exam? Shoot those my way. Other than that, sign up for the final, prepare for the final, and good luck.